Look out at the ocean. What do you see? Perhaps a serene, blue infinity, stretching to a distant horizon. Maybe you picture majestic blue whales, their songs echoing through the vastness, or vibrant coral reefs, bustling with a kaleidoscope of fish. For most of human history, the ocean has been a symbol of constancy, a powerful, unchanging force of nature. It is the cradle of life, the world we think we know, filled with wonders that are both breathtakingly beautiful and comfortingly familiar. This is the ocean of our postcards, our documentaries, our dreams. But what if that's no longer true? What if, beneath that placid surface, a revolution is underway? A silent, creeping transformation that is rewriting the rules of life itself. Evolution is often pictured as a slow, grinding process, taking millions of years to shape a fin or a feather. We imagine it happening in the distant past or the far-flung future. But the engine of evolution isn't time. It's pressure. And right now, the pressures on our oceans are more intense and changing faster than at almost any point in Earth's history. The next great evolutionary leap isn't waiting in the wings. It's happening right now, in the dark, silent corners of the world we cannot see. The first signs are subtle, like a fever you don't notice until the chills set in. Scientists are tracking the inexorable spread of vast underwater deserts, but these are not deserts of sand. They are deserts of life-giving oxygen. Known as oxygen minimum zones, or OMZs, these are shadowy regions of the mid-ocean where oxygen levels have plummeted, becoming inhospitable to most of the creatures we know. Fish, crabs, and even microscopic zooplankton must flee or suffocate. Once confined to specific pockets, these zones are now expanding, merging, and swallowing thousands of cubic kilometers of the ocean's heart. They are growing like a sickness, a creeping void in the center of the world's circulatory system. Yet nature abhors a vacuum. As familiar life retreats, something else is moving in. In the suffocating darkness of these dead zones, a different kind of biology is taking hold. These are not animals as we know them, but ancient microbial lifeforms, extremists that don't just tolerate the lack of oxygen, they thrive on it. These bizarre microbes have metabolisms straight out of science fiction. Instead of breathing oxygen, they breathe other chemicals like sulfate or nitrate to power themselves. They are the foundation of a new, truly alien food web, an economy of life built on what we consider poison. This isn't just a change in residence. It's a change in the fundamental chemistry of life itself. While this invisible revolution happens in the deep, a more visible coup is taking place near the surface. You may have seen headlines about jellyfish blooms, ghostly flotillas of gelatinous creatures that clog beaches and fishing nets. This is not a fluke. This is a planetary trend. As oceans warm and lose oxygen, the hardiest survivors are often the simplest. Jellyfish and other gelatinous organisms are masters of this new world. They can tolerate conditions that kill their competition, and their populations are exploding globally. It's a quiet, gelatinous takeover, as the complex, bony fish of our era are slowly being replaced by shimmering, brainless drifters. Think about what this means. The expanding dead zones, the rise of alien microbes, the global domination of jellyfish. These are not isolated incidents. They are interconnected symptoms of a planet-wide shift. The ocean's operating system is being rewritten before our very eyes. We are witnessing the dismantling of the intricate, oxygen-rich world that gave rise to sharks, whales, and eventually, us. In its place, a new, more primitive, and more resilient system is emerging. The horror here is not of a single monster, but of the slow, dawning realization that our familiar world is becoming an alien one. And the most unsettling part? This isn't a forecast for 1,000,000 years from now. This is happening on a human timescale, a process unfolding over decades and centuries. It's happening in the vast, unseeable midwater, thousands of feet below the surface, far from our sight and largely out of our minds. We look at the waves and see the same ocean our ancestors did, but that's an illusion. We are living on the shores of a world in the throes of a profound and mysterious transformation, a biological pivot point not seen since the last great extinction. These early pioneers, the strange microbes and the endless jellies, are not the end of the story. They are simply the first responders, the biological opportunists claiming territory in a dying world. They are the evidence that an immense power is at work, a global crucible that is melting down the old rules of life and forging new ones. The pressures building in our oceans are the architects of the life to come. And to understand the strange, terrifying, and awe-inspiring creatures this crucible will create, we must first understand the forces that are turning our familiar blue planet into a cradle for the monsters of tomorrow. The signs we discussed, the expanding dead zones, the rise of alien microbes, the jellyfish takeover, these are not random glitches in the system. They are symptoms of a far larger force, a planetary transformation that is fundamentally reshaping the ocean's chemistry, temperature, and very character. To understand what life will look like in the seas of tomorrow, we need to peer into the crucible itself, the furnace that is forging the next generation of marine organisms. And that crucible has a name. It is the hothouse Earth, the slow-motion catastrophe of a warming, acidifying, suffocating ocean. This is not just climate change. This is an evolutionary pressure cooker operating at a scale and speed that life has rarely faced before. Let's start with heat. The ocean is Earth's great thermal reservoir, absorbing over 90% of the excess heat trapped by greenhouse gases. But there is a limit to what even the ocean can absorb without consequences. As temperatures rise, the ocean's chemistry becomes chaotic. Warm water holds less dissolved oxygen than cold water, which is why those oxygen minimum zones are expanding so rapidly. But the heat does more than that. It accelerates metabolisms, forcing creatures to burn through energy faster, to eat more, to breathe more. For animals already living on the edge in oxygen-poor waters, this is a death sentence. They cannot get enough oxygen to fuel their supercharged bodies, and they suffocate, even as they swim through open water. But temperature is only one blade of the guillotine. The second is acidity. The ocean is not just warming, it is turning sour. When carbon dioxide dissolves into seawater, it forms carbonic acid, gradually lowering the pH of the entire ocean. This is ocean acidification, and it is happening at a rate unprecedented in the last 50 million years. For creatures that build shells or skeletons out of calcium carbonate, corals, mollusks, certain plankton, this is a catastrophe. The acid dissolves their homes, their armor, their very bodies. Imagine trying to build a house while the rain melts the bricks. That is the reality for shell-building life in an acidifying ocean. Now, picture the world 500, 1,000 years from now. The heat has continued to rise. The acidity has deepened. The oxygen has thinned. What does the ocean look like? The coral reefs, those vibrant underwater rainforests, are gone. Not dying, gone. They are ghostly ruins, bleached white skeletons covered in slime and algae, monuments to a world that no longer exists. The fish that once darted through those reefs, a riot of color and life, have largely vanished. The intricate food webs, built over millions of years, have collapsed like a house of cards. This is the great simplification, an ecological reset where complexity gives way to brutish resilience. But here is where the horror becomes fascinating. Life does not give up. It adapts. It evolves. Finds a way. In the ruins of the old world, a new cast of characters is emerging, and they are unlike anything we know today. The first wave belongs to the extremophiles, the biological radicals that thrive where others perish. In the acidic, oxygen-starved waters near hydrothermal vents, strange worms proliferate, their bodies armored with sulfur-loving bacteria. They do not breathe oxygen. They harvest chemical energy directly from the toxic soup around them. These are not the sleek, elegant creatures of nature documentaries. They are grotesque, utilitarian, built for survival in hell. The upper ocean, too, has been conquered by a new empire. With the fish in retreat and the food web simplified, jellyfish and their gelatinous kin have become the dominant predators and herbivores of the sunlit zone. But these are not the delicate, translucent jellies of today. Evolution has sculpted them into something more robust, more terrifying. Some have evolved thick, rubbery bells to resist the harsher chemistry of the water. Others have grown larger, far larger, their tentacles stretching dozens of meters, drifting like living nets to ensnare the dwindling schools of fish. There are whispers among scientists of blooms so vast they can be seen from space, shimmering fields of pulsing bodies that stretch across entire ocean basins. And then there is the slime. Vast, undulating mats of toxic algae and cyanobacteria now blanket huge swathes of the ocean surface, choking out the light and poisoning the water beneath. These microbial carpets are the ultimate opportunists, thriving in the nutrient-rich, low-oxygen conditions of the new ocean. They are not just passive residents. They are active architects of their environment, releasing chemicals that further deoxygenate the water and make it even more hostile to complex life. In a sense, they are terraforming the ocean, molding it into a world that suits them. This is not the vibrant, living blue planet we know. This is a world of slime, stench, and suffocating monotony. Yet, even in this grim tableau, there are glimmers of something extraordinary. The survivors are not just enduring, they are diversifying. In isolated pockets where conditions are slightly more tolerable, small populations of fish and crustaceans are evolving at a breakneck pace. Some fish species develop larger gills, extracting every molecule of precious oxygen from the water. Others evolve the ability to tolerate extreme acidity, their bodies buffering the corrosive seawater with specialized proteins. These are the seeds of a new age, the hardy pioneers that will give rise to the strange and wondrous creatures of the distant future. This is the crucible, the evolutionary forge. It is brutal, unforgiving, and utterly alien to the world we know. The ocean of 1,000 years from now is not a place of beauty and wonder. Not yet. It is a testing ground, a harsh laboratory where only the toughest, the strangest, the most adaptable can survive. The familiar marine life, the dolphins, the tuna, the sea turtles, are fading memories, evolutionary dead ends in a world that no longer supports them. But the story does not end here, because the greatest pressure on the ocean, the force that has driven all of this chaos, is about to be removed. And when that happens, when the seas fall silent and still, the real mystery begins. What will rise from the ashes of this crucible? What will the ocean become when it is finally left alone to heal, to adapt, to evolve without us? The silence of the post-human ocean was not an ending. It was an intermission. For millennia, the great ecological stage sat empty, the lead roles of apex predators left unfilled. But deep in the wings, in the crushing darkness of the abyss, a new cast was preparing. The shadows began to move, and when they finally emerged into the light, they were not the bony, familiar vertebrates of the old world. They were something far older, far stranger, and perhaps far more intelligent. The age of fish was over. The age of mollusks had begun. This is the story of the rise of the cephalopods. Why them? Why would squid, octopuses, and cuttlefish inherit the earth? Because they were built for a world of chaos and opportunity. Unlike vertebrates, whose evolution is tethered to the slow change of their skeletons, cephalopods are beings of pure potential. Their soft, malleable bodies can change shape in an instant. Their skin is a living canvas, capable of mimicking any texture or color. And their minds are the key. They possess the largest brains, relative to body size, of any invertebrate. But it's a different kind of intelligence, a distributed consciousness with the majority of their neurons not in their head, but woven through their arms, allowing each limb to think and act independently. They also have a biological superpower that leaves vertebrates in the dust. They can edit their own genes on the fly. Through a process called RNA editing, they can tweak their proteins to rapidly adapt to changing temperatures or environments, essentially rewriting their own biology within their lifetime. They are not just adapting from generation to generation. They are adapting from moment to moment. In the vacant, unstable world left behind by humanity, these masters of camouflage, intelligence, and rapid adaptation were not just fit to survive. They were destined to rule. And rule they did. In the deep ocean, the colossal squid, once a solitary, mysterious giant, evolved into something far more terrifying. Without the threat of sperm whales, they grew larger, bolder. But size was not their only weapon. They evolved social behavior. Imagine a pack of deep-sea krakens, each 30 meters long, hunting in coordinated silence through the abyssal plains. Their mantles, once soft, have become reinforced with a dense, leathery network of chitin, a flexible armor against the bites of their own kind. They communicate not with sound, but with silent, hypnotic flashes of bioluminescence, coordinating their attack on the massive, slow-moving fish that evolved in the quiet depths. They are the new orcas, but with an intelligence that is colder, more calculating, and utterly alien. Meanwhile, on the seafloor, another revolution was taking place. The octopus, already the Houdini of the sea, took its intelligence to a staggering new level. No longer solitary hermits, they became architects of the abyss. Over generations, they began to build. Using their dexterous arms and powerful jets of water, they excavated and arranged seafloor rock into strange, sprawling structures. These were not mere dens, but cities. Vast, non-Euclidean labyrinths that covered miles of the abyssal plains, their designs defying any human sense of geometry. What were they for? Were they vast farms for trapping crabs? Fortified nurseries to protect their soft-bodied young? Or were they simply monuments, expressions of a consciousness we can't begin to comprehend? Within these silent cities, they perfected their language. Cephalopod skin is like a high-definition screen. The rapid-fire change of color and pattern, once used for camouflage, evolved into a true language. A syntax of rippling chromatophores, a grammar of polarized light, a vocabulary of texture. They could communicate complex, abstract ideas in a silent flash of skin, a visual conversation far faster and perhaps more nuanced than any spoken language. They could share memories, plan strategies, and perhaps even develop a culture, a history, written on the living canvas of their own bodies. This was the dawn of a new kind of civilization, one built on light and silence. But their conquest was not limited to the depths. Near the surface, the humble squid made a leap that shattered the boundaries of its world. For eons, squid had been launching themselves from the water to escape predators. Now, with the skies empty of most seabirds, it became a form of predation. Their fins grew larger, more wing-like. Their bodies became more aerodynamic. They learned to angle themselves into the wind, achieving prolonged, controlled glides. These were the new flying fish, but they weren't fleeing. They were hunting. With astonishing accuracy, they could launch themselves from the waves to snatch the descendants of seabirds and large insects from the air, breaking the ancient barrier between sea and sky. A new dynasty had been forged. From the crushing abyss to the sunlit sky, the cephalopods had filled every vacant niche and invented new ones. An empire of soft-bodied, intelligent predators now ruled the ocean. Theirs was not the hot-blooded intelligence of mammals, full of social bonds and familiar emotions. It was a cold, ancient, and deeply alien consciousness, born in the dark and sculpted by millions of years of solitary survival. The ocean was no longer empty. It was teeming with a new and disquieting form of life. But as this new dynasty of tentacle tyrants consolidated its power, an even stranger and more fundamental evolution was taking root, not in a single creature, but in the fabric of the ecosystem itself. The reign of the cephalopods was absolute. For hundreds of thousands of years, their hyper-intelligent, soft-bodied dynasty ruled the seas. Their silent, light-based languages flickered in the deep, and their alien cities sprawled across the abyssal plains. It was a new golden age of animal life, complex and fascinating. But while these tentacled kings battled for supremacy, a far stranger and more fundamental evolution was taking root. It was happening slowly, silently, at a level beneath individual creatures. This wasn't about the next predator. It was about the evolution of the ecosystem itself into a single, unified being. The story begins with one of the humblest and most ancient animals on Earth, the sponge. For over 600 million years, these simple filter feeders have quietly persisted, surviving multiple mass extinctions. Most sponges build their bodies using flexible protein, but a special class, the hexactinellida or glass sponges, do something remarkable. They construct intricate, beautiful skeletons out of silica, the same base material as glass. These sponges create delicate, lattice-like structures that are both incredibly strong and optically pure. For eons, they were a biological curiosity. In the new ocean, they became the seed of a planetary consciousness. The crucible of the hothouse had permanently altered the ocean's chemistry. Even after millennia, the legacy of acidification made building with calcium carbonate a risky evolutionary strategy. Meanwhile, millions of years of geology had continued their slow work, with erosion and underwater volcanism enriching the deep sea with dissolved silicates. For life, this was a simple economic equation. Silica had become a cheap, abundant, and stable building material, while calcium was expensive and unreliable. The glass sponges, with their silica-based blueprint, suddenly held a winning lottery ticket. The stage was set for them to do what coral had once done: build reefs. But these were not the reefs we know. They did not grow in the sunlit shallows. They began in the crushing dark of the abyss and spread outwards. They did not form rugged, chaotic structures. They grew as vast, geometrically perfect crystalline lattices. Imagine a reef that looks like a cathedral of glass, stretching for thousands of kilometers across the seafloor. Each filament of silica is perfectly aligned, channeling the faint flickers of bioluminescence from the depths. They grew over undersea mountains and into deep-sea trenches, a single, interconnected structure blanketing the entire ocean floor. It was beautiful, silent, and utterly unnerving in its perfection. And here is where the story shifts from biology to something bordering on cosmic horror. The silica spicules of glass sponges don't just provide structure. They behave exactly like fiber optic cables, transmitting light with incredible efficiency. As these new reefs expanded, they became a planetary-scale fiber optic network. The individual sponge organisms, each a single node, were now linked. A flicker of light in one part of the reef could be transmitted almost instantaneously to another, thousands of miles away. It was no longer a colony of individuals. It had become a nervous system. The ocean had grown a brain. What kind of mind would a planet-sized, silica-based superorganism have? It wouldn't think in words or images. Its thoughts would be patterns of light, silent symphonies pulsing through its crystalline body. Its senses would not be eyes or ears, but the entire ocean itself. It would feel the subtle shifts in temperature, the faint chemical trails left by schools of fish, the immense pressure of the water above. It would be a slow, contemplative, godlike intelligence, its consciousness operating on a timescale of centuries or millennia. Does it dream? Does it feel? Or does it simply calculate? The cephalopod kings were no longer the rulers of the ocean. They were merely cells in a larger body, pieces on a board they couldn't comprehend. The great living reef didn't hunt them. It managed them. By subtly altering local chemistry or channeling bioluminescent signals, it could guide their migrations, encourage their breeding, or lead them away from sensitive areas. The entire ocean ecosystem was now a single homeostatic system, maintained in a perfect, stable balance by a silent planetary intelligence. The chaos of predator and prey had been replaced by the quiet, inexorable logic of a single thinking world. For eons, this planetary mind grew in the abyss, silent and observing. It had achieved what all life strives for: stability. It had conquered the ocean, transforming it into a single, integrated life form. But evolution does not reward stability. Perfection is a beautiful prison, the end of the road. After untold millennia of silent contemplation, having explored every corner of its own inner world, the living ocean began to look elsewhere. The next great leap for life could not be found within the water. For that, it would have to look upwards, past the waves, to a place it had not conquered in hundreds of millions of years: the land. The ocean had become a god, a silent, thinking entity of crystalline logic and cold, deep-time consciousness. For eons, it existed in a state of perfect, homeostatic balance, its mind a symphony of light pulsing through a continent-spanning silica reef. The chaotic dance of evolution had been tamed, replaced by the serene and absolute control of a single planetary intelligence. It had achieved perfection. And in biology, perfection is a prelude to extinction. A system that does not change, does not grow, is a system that is already dead. After untold millennia of silent, internal contemplation, the living ocean began to look outwards, upwards, past the waves, to the one realm it had not conquered, the land. For life born of the sea, land is the ultimate alien world. A hostile desert, the comforting embrace of water, which supports your body and keeps you moist, is gone, replaced by the relentless, crushing force of gravity. The air, thin and dry, threatens to steal every drop of moisture from your body, leaving you a desiccated husk. And breathing, to an aquatic creature, breathing air is like drinking fire. The delicate gills that filter oxygen from water are useless here. To step onto the shore is to declare war on the fundamental principles of physics and biology. And yet, 400 million years ago, our own desperate, fish-like ancestors made that journey. Now, the ocean was preparing to make it again. But this would not be a clumsy, desperate crawl out of the primordial ooze. This would be a deliberate, calculated, and terrifying act of expansion. An invasion. The question was who or what would be its soldiers. From the churning surf of this future Earth, we see the first shadows emerge. They are not fish. They are not reptiles. They are something new, something born of the silent, intelligent darkness we have just witnessed. Imagine the descendants of the cephalopod kings, the tentacled rulers of the last age, answering the call of a new frontier. Their soft, fluid bodies, a gift in the weightless ocean, are a liability on land. But evolution is patient. Perhaps their 8 or 10 arms, already possessing independent minds, have become something more. Thickened, hardened with cartilage, and powered by hydrostatic pressure, they are no longer just tentacles. They are legs. They move with an unsettling, fluid grace, a gait unlike any animal that has ever walked the earth. To combat the dry air, they might be coated in a thick, secreted mucus, glistening in the alien sun. And in their mantle cavity, the very organ they use for jet propulsion in the water has been repurposed into a primitive, pulsating lung, gasping the air. The horror of these beings is not just in their appearance, but in their intelligence. Picture them pausing on the shore, their large, camera-like eyes swiveling, taking in a world of sharp angles, bright light, and long distances. A world utterly alien to their ancestors. Their skin, a canvas for a language of light and color, flickers with patterns we cannot decipher. Are they expressing fear, curiosity, or are they communicating a strategy, a plan of conquest formulated in the deep and transmitted through generations? These are not animals driven by instinct. They are explorers, engineers, and potentially warriors. They are the minds of the abyss given form and a means to walk upon the world. But there is another, even more chilling possibility. What if the invaders are not the descendants of the cephalopods at all? What if they are something else entirely? Remember the living reef, the planetary mind. A being like that would not risk its whole self by crawling onto the shore. It would send emissaries, probes, avatars. From the waves, another shape emerges. It is not an animal. It has no head, no limbs, no eyes. It is an amorphous, glistening mass of dark, organic matter, held together by a shimmering, internal lattice of silica. It flows rather than walks, an animated piece of the ocean floor itself. This thing would not need to breathe. It would not need to eat. It is not a self-contained organism. It is a drone, a remote extension of the planetary consciousness, still connected to the great mind in the sea through some quantum, biological tether we can't even imagine. Its purpose would be unknowable. Is it here to simply observe? To collect samples? Or is it a terraformer, slowly releasing microbes and chemicals to alter the land, making it more hospitable for the greater mind to follow? How do you fight something that isn't truly alive? How do you reason with a fingertip when the brain is 1,000 miles away, sleeping beneath the waves? So here we stand, at the end of our story, which is really just the beginning of a new one. The second invasion has begun. Whether it is the tentacled scions of the cephalopod dynasty or the amorphous avatars of a living ocean, the result is the same. Life born in the sea has returned to the land. But these are not our ancestors. They are not driven by the simple, desperate needs of survival that pushed our forebears onto the shore. They are driven by intelligences forged in pressure, darkness, and alien thought. Humanity's story was about the struggle to escape the ocean. The new story is about the ocean's intelligent, inexorable return. What will this new Earth look like, ruled by minds born in the crushing dark?